Question 1. A started a work and left after working for 2 days. Then B was called and he finished the remaining work in 9 days. Had A left the work after working for 3 days, B would have finished the remaining work in 6 days. In how many days they will finish the whole work working together? Option A 5 days, option B 3 by 4 days, option C 6 2 by 3 days, option D 4 2 by 3 days, and option E 4 3 by 4 days. So this is a question from time and work section, and hope you have solved questions from this section. Anyway, I'll explain how we can do it. So solving these questions, we have 3 equations to remember. Work, that is W, is equal to time T into efficiency E, or efficiency is equal to work divided by time, or time is equal to work divided by efficiency. So these 3 equations you have to remember to solve these kind of questions. So let's see how we can solve this question. Okay, we have 2 persons working, that is A and B. So let's consider that A's efficiency is small letter A and B's efficiency is small letter B. Now A started the work and left after working for 2 days. Then B was called and he finished the remaining work in 9 days. Then what will be the total work? A worked for 2 days. Therefore, the work A did will be 2. That is, time is 2, and efficiency of A we took as small letter A. Therefore, work by A will be 2A. And work by B will be, because B worked for 9 days and B's efficiency we considered as small letter b, therefore work by B will be 9B. And it is said that the whole work was done by A and B working together for 2 and 9 days respectively. Therefore the total work will be W is equal to WA plus WB, that is 2A plus 9B. This is our total work. That's written here. Also, it is said that had A left the work after working for 3 days, B would have finished the remaining work in 6 days. That means again we have a condition that A is working for 3 days. If A works for 3 days, then work of A will be 3 into A. And then if A works 3A, then the remaining work is finished by B in 6 days, which means the work done by B will be 6B. So this is equal to the work we calculated before. That is, again we have an equation W is equal to WA plus WB, that is W is equal to WA plus WB, that is 3A plus 6B. So the work is same in both the ways. Therefore we can equate the previous equation with this equation, that is 2A plus 9B is equal to 3A plus 6B. The work is same in both the conditions. Hence, we can equate these 2 equations. Now, solving this, we get 3B equal to A. That is 2A plus 9B is equal to 3A plus 6B. 6B goes here and 2A comes here. Therefore, we get 3b is equal to a, or a by b is equal to 1. Sorry, a by b is equal to 3 is to 1. So we can consider a as 3, a equal to 3 and b is equal to 1. Let's take a is equal to 3 and b is equal to 1. Then what will be the work? The work is equal to either 2a plus 9b. You can substitute the values of a and b in this, or we have another equation, work is equal to 3a plus 6b. So substitute the value of a and b in any of these equations. So here I am substituting a and b in 2a plus 9b. Therefore we get the work is equal to 2 into 3 plus 9 into 1, which is equal to 15. Now we have to find in how many days they will finish the work working together. So we have that. We know that time is equal to work by efficiency. So what is the work? 15. What is the total efficiency? Because A and B are working together, therefore the total efficiency will be 3 plus 1, that is 15 divided by 4, or it is 3 by 4. Therefore 15 by 4 or 3 by 4 days is the answer. Next question. The ratio of efficiencies of A, B and C is 2:3:4. While A and C work on alternate days and B work for all days. Now the work completed in total 10 days and total amount they get is rupees 1200. Find the amount of each person respectively. Option A, rupees 200, rupees 600, rupees 400. Option B, rupees 500, rupees 500, rupees 200. Option C, rupees 600, rupees 400, rupees 200. Option D, rupees 400, 200 and 600. And option E, 450, 150 and 600. This is again a time and work question. So we have the efficiencies of A, B and C in the ratio 2:3:4, and it is given that the work was completed in total 10 days, in which A and C work on alternate days and B work for all days. The work was completed in 10 days. A and C work for alternate days while B work for all the days, which means B worked for all the 10 days while A and C worked for only half of the days. Half of the total number of days, that is 5. Now it is given that the ratio of their efficiencies is 2:3:4. So we consider efficiency as 2:3:4. Now we know that work is equal to time into efficiency. Hence the amount of work done by A, B and C respectively will be 2 into 5, 10, 3 into 10, 30, 4 into 5, 20. Now we have the work of A, B and C respectively as 10, 30 and 20. So if you have a doubt that if this is only the ratio, how we can ensure that this is the work? Because anyway even if this is a ratio, let's put x here, 2x, 3x and 4x. The work will be 10x, 30x and 20x. And when we calculate the wages, we are calculating according to the amount of work they done out of the total work. Therefore x and x cancels. Hence we don't have to put x here. We just have to calculate the value as shown on the table. Therefore we get the work of A as 10, work of B as 30 and work of C as 20 if 60 is the total work. Therefore, how we will calculate the wages? The wages are given according to the amount of work the person does. Therefore, A will get 10 by 60 into the total wages, that is 1200, that is 200. A will get 200. Similarly, B will get 30 is the amount of work he done and 60 is the total work into the total wages is 1200. Therefore, B will get 600 and C will get similarly 20 by 60 into 1200, which is equal to 400. Hence, the amount each person will receive respectively are 200, 600 and 400. Now the third question. A pipe can fill a cistern in 12 minutes and another pipe can fill it in 15 minutes, but third pipe can empty it in 6 minutes. The first two pipes are kept open for 5 minutes in the beginning and then the third pipe is also opened. Time taken to empty the cistern is option A 38 minutes, option B 22 minutes, option C 42 minutes, option D 45 minutes and option E 60 minutes. So this is a question related to the topic pipes and cisterns. So here also we have some equations to remember, that is capacity of the tank C is equal to time taken by the pipes to fill or empty the tank into efficiency of the efficiency of the pipe. So this is similar to the equation I explained for work and time. So just remember this. In this similar way, we can calculate time as capacity by efficiency and efficiency as capacity by time. Just not this. Now let's go to the question. Okay, so we have, and also we have to remember that capacity is equal to LCM of the times given. That is, if we are given the times taken by different pipes, then the capacity of the cistern is calculated as the LCM of the times given. So what will be the capacity of the tank in this case? Because we have the times of pipe 1, pipe 2 and pipe 3 as 12, 15 and 6. Now what is the LCM of 12, 15 and 6? 60. Hope you know to calculate the LCM. So the capacity of the cistern is 60 liter. That is the LCM of 12, 15 and 6. Now the efficiency of the pipe 1 will be 60 by 12, 60 by 12, which is 5. Efficiency of the pipe 2 will be 60 by 15, that is 4. And efficiency of pipe 3 will be 60 by 6, that is 10. And it is given that pipe 1 and pipe 2 is filling pipes, but the third pipe is emptying the cistern, which means it is a leakage. Therefore, we consider the efficiency as minus 10. Actually, what this means? That is, the pipe 1 fills the cistern by 5 liters in 1 minute, while the pipe 2 fills the cistern by 4 liters in 1 minute, while pipe 3 empties 10 liters in 1 minute. Therefore, if in 1 minute 5 and 4, so if in 2 minutes The pipe 1 and pipe 2 will together fill 5 plus 4, 9 into 2, that is 18 liters. But when the pipe 3 is also opened, it will leakage 10 liters, which means the remaining will be only 8 liters in the cistern. So in the question it is said that the first two pipes are kept open for 5 minutes in the beginning. Hence, how much liters of water will be filled in the cistern in 5 minutes? First 5 minutes, 5 into 5 plus 4, that is 5 into 9, that is equal to 45 liter. Now, after pipe 1 and pipe 2 fills 45 liters in the tank, pipe 3 is also opened, which means the effective thing that happens in the cistern will be, that is in each minute it will leakage 1 liter. How? Because 5 plus 4 minus 10. Therefore, 5 plus 4 minus 10, which is equal to minus 1, which means after pipe 3 also joins, the cistern will be emptied by 1 liter in each minute. Therefore, we have 45 liters already in the cistern, and after pipe 3 joins, every minute 1 liter is leakaging, which means it will take 45 minutes to leakage all the 45 liters we already have in the cistern. Hope you understood this. So let's go to the fourth question. Karan and Arjun run a 100-meter race where Karan beats Arjun by 10 meter. To do a favor to Arjun, Karan starts 10 meter behind the starting line in a second 100-meter race. They both run at their earliest speeds. Which of the following is true in connection with the second race? Option A, Karan beats Arjun by 1 meter. Option B, Arjun beats Karan by 1 meter. Option C, Karan beats Arjun by Option C, Karan beats Arjun reaches at same time. Option C is Karan and Arjun reaches at same time, and option D, Karan beats Arjun by 10 meter, and option E, none of this. So let's Karan's speed be x meter per second and Arjun's speed be y meter per second. The race was a 100-meter race. So it is said that the Karan finishes 100 meter and Arjun and he beats Arjun by 10 meter, which means Arjun will cover 90 meter while Karan covers 100 meter. Therefore, the time will be same for Karan and Arjun to cover 100 meter and 90 meter respectively. Therefore, 90 can be written as x into t and 100 can be written as 90 can be written as y into t, because we have Arjun's speed as y, and 100 meter can be written as x into t, or t is equal to 100 by x or 90 by y. That is written here. 100 by x is equal to 90 by y is equal to t. Then from this we get that the ratio of the speeds of Karan and Arjun as 10:9. That is, solving this we get x by y as 10 by 9, or the ratio of their speeds as 10:9. Now in the second race, this is a 100 meter and this is 10 meter behind it, and Karan starts from here, Arjun starts from here. Therefore, in 10 minutes, just consider examples. So in 10 minutes, Arjun will cover 99 meter while Karan will cover 100 sorry so this is a 100-meter race. This is 10 meter behind it, and current starts from here. Arjun starts from here in the second race, and Arjun has to run 100 meter and Karan has to run 110 meter to reach the finishing point. So if in 10 minutes, how much distance will Arjun cover? 90, because the speed of the Arjun we can consider it as 9 meter per second. Then in 10 seconds, Arjun will cover 90 meter, while Karan will cover 100 meter. So they both reach in the same point. Now in another second, in 11 seconds, Arjun will cover 99 meter, whereas Karan will cover 110 meter. So after covering 110 meter, he reaches the finishing point, but Karan has covered 110 meter and he reaches the finishing point, but Arjun has covered only 99 meter, so he reaches only 1 meter behind Karan. Therefore, in the second race, Karan will run 110 meters while Arjun will run only 99 meters. After running 110 meter, Karan will reach the finishing point, but Arjun will not reach because he would have covered only 99 meter, and hence he will be 1 meter behind Karan. Hope the video was helpful. Please let me know the feedback.